In this lesson, we're going to work with tangents, and we're going to extend them into more difficult types of problems involving tangents. So our objective is I can solve problems involving tangents. In this problem, what we're going to do is what's called a walk-around problem. We've got a circle that's inscribed inside this quadrilateral, and what we want to do is solve for some missing information by walking around the quadrilateral to find the missing information. So let's start by labeling our information. AB is equal to 6 here. So that length is 6 units long. We've got BC equal to 5. So from there to there is 5. And then we've got AD equal to 8. Now let's start the problem. We want to find this missing side CD. Now we oftentimes will assign something missing that we're trying to find that value X. In this case, I'm going to hold off on doing that. The technique is to go to the side where we've got information, start there. We don't know any of these smaller values, so I'm going to call this X, and that would make this X also because it's a common tangent problem that from point A, those two tangents are going to be equal to each other. Now let's walk around both ways around this quadrilateral. Let's start with going to this way. If this whole side is 6 and this is X, that would make this 6 minus X. That would make this side from point B to this point here also 6 minus X. Now what we'll do is we'll extend and say, hey, how about from that point to C? Well, if this whole length is 5 and this smaller piece is 6 minus X, that would make this 5 minus 6 minus X. And we can now extend that up to here from C to this point. These two tangents are going to be congruent, so I'll put their measures equal, so 5 minus 6 minus X for this segment there. Now let's walk around the other direction as well. So if this is X, over here this would be 8 minus X. Now what I can do is say that this tangent will be congruent to that one, so their measures are equal, so this will be 8 minus X. What we've done is had them arrive now to meet on our side CD that we're trying to find. Let's go ahead and add these two smaller pieces together to equal CD. So CD will equal this part here, 5 minus the 6 minus X. And it will, if we add it to, we're going to add it to this segment here to get the whole length, so that's 8 minus X. Now, let's simplify this side. What happens is 5 minus, I'm going to do distribute through the minus sign, so 5 minus 6, distribute through the minus to the minus X becomes a plus X. Over here, it's just a plus, so I have plus 8, and then minus X. I don't have to distribute, well, the distributing the plus sign leaves them the same. Now when I simplify, notice that this X and this minus X, the unknowns, they're eliminated. So what I get is 5 minus 6 is negative 1. Negative 1 plus 8 is equal to 7. So I get that my CD is equal to 7. We've walked around the problem, used what we do know about those common tangents, and then found the final solution by simplifying our result. Let's try another one. This one is going to be a little different, okay, than the walk around. This is another common type of problem called an external tangent problem. This external tangent problem has certain techniques. What it tells us is it gives us what these radii are. So let's go ahead and draw those in. The radii of circle C, I'm going to just draw from here to here, and that's equal to 7 units. Also, they give me the radius of circle Q as 10. So that's 10 units. Now, what I do know about these problems, remember a radius to a point of tangency, when you have a tangent, it gives me a right angle. So these are right angles. Now here's the secret step. Before I got two secret steps I'm going to do with you. The first one is I'm going to draw a line that's parallel to this tangent over to this other radius. So draw that line in, because what I have now, since this is parallel and I've got right angles, that's a rectangle. And I know that the opposite sides are going to be congruent. So if I'm trying to find the length of AB from A to B here, I know that it's going to be the same as this green line as well. Well, we know some information here. If this is 7 and this whole thing is 10, notice that this will be 7 there. That leaves 3 for this little point from the center to where that parallel side intersects it. So I now have that little 3. So that's step one. Kind of the secret is to draw that parallel segment in and use that to get more information. Now here's the second secret step is I'm going to connect the centers. These two, when I connect them with this purple line, what I've got is that this is a right triangle here because it's parallel. That gives me congruent angles there, and that's congruent to that right angle. Gives me a right angle there. I know the length of this purple segment because this radius is 7, this radius is 10, so from here all the way over here, that is going to be 17 when I add them together. What I now have, and I'm going to draw it out here, my green side, and then I've got this little red segment, and then I've got the purple one. This is a right triangle. This side here is 3, this side is 17. I'm going to find the green length by using the Pythagorean theorem. I'll just call this side x. And so what I have is x squared, it's a leg, plus the other leg squared, 3, is going to equal 17 squared. Pythagorean theorem. When I add those together, I get 289 for 17 squared. This is 9 for the 3 squared. Subtract 9 from both sides, and you get 280. And so x, when I take the square root of both sides, is going to be the square root of 280. That's the length of my green side here, which is the same as length of B. So if I round that to, let's say, a couple decimal places, AB is going to be equal to about 16.7 when I round the square root of 280. It also asks me here for CQ. Notice we use that CQ here, and so CQ was equal to 17 as part of that problem. So we can use this to solve this external tangent problem. The secret is to first of all draw a parallel side to the tangent problem that the tangent that you're trying to find. Draw that inside to get more information using the radii. Then connect the centers. Get what that length is. You now have a right triangle. Solve the right triangle for the missing information, and you've solved your tangent problem.